In one of Belgium's most important industrial cities, right in the heart of Charleroi, a vast complex of steel, concrete and rust rises into the skyline. In the first episode of this massive lost place, we explored the coal bunker and the coke plant, where hard coal was once transformed into coke and various byproducts. In this episode, we explore the power plant and the turbine hall of the site and discover how the byproduct coke oven gas was reused within the facility. Join us as we explore this impressive lost place. On the site, there was an on-site power plant with a medium pressure and a high pressure boiler house, often referred to in the urbex scene as the blue power plant. Like many former sites of the Belgian steel industry, this complex is disappearing piece by piece. During the production of this video, demolition was already well underway, and numerous buildings had already been demolished or disappeared shortly after our filming. The coke oven gas produced was reused here in the medium pressure boiler section, where it was burned as fuel in large boilers. This generated steam, which was primarily used as process steam for numerous applications within the plant, such as heating processes and supporting various stages of production. The upper level of the medium pressure boiler house was dedicated to the boiler's exhaust gas system. Large insulated ducts collected the hot flue gases before directing them through vertical chimneys that discharged them directly above the roof. Powerful fans provided the necessary draft, ensuring the safe and efficient operation of the entire boiler plant. This area also housed a conveying system with a bucket elevator, conveyor belts and storage hoppers. It most likely transported coke grease or pulverized coal, which served as supplementary fuel for the boilers. In the same building complex, there was also the more modern high-pressure boiler house, which was primarily used to generate high-pressure steam for power generation. This steam was used to drive turbines and thus produce electrical energy for the operation of the entire plant. The facility was mainly powered by blast furnace gas, a byproduct of iron production in the nearby blast furnace. Due to its low calorific value, it was often supplemented with coke oven gas, which provided more stable combustion. In the same building as the high-pressure boiler house, there was also a huge, impressive turbine hall. Here once stood massive steam turbines, driven by the high-pressure steam generated in the boiler house. The steam set the turbines in motion, which in turn drove generators and produced electrical energy for the entire operation. The power plant with its turbine hall is often referred to in the urbex scene as the blue power plant. The name originates from a large blue-painted Escher-Weiss turbine inside the facility, which gave the site its unofficial name after it was shut down. The enormous size of the hall was no coincidence. The turbines and generators were massive machines that not only required a lot of space, but also sufficient clearance for maintenance, cooling, and safe operation. In addition, heavy components had to be installed and moved, which required great hall heights and large overhead crane systems. Next to the turbine hall, there was also a large control room from which the entire energy production was managed. Here, Workers monitored pressure, temperature, and system performance, ensuring that power generation ran smoothly around the clock. The power plant complex also included a large cooling tower. Such structures were necessary to dissipate the waste heat generated during energy production. During operation, heated water from the system was directed into the cooling tower, where it was cooled down and then reused. In this way, a closed cooling cycle could be maintained, which was essential for the continuous operation of the turbines and boilers. In the lower part of the cooling tower, there was a basin where the warm cooling water from the power plant was collected. From there, it was pumped up through a central pipe system inside the tower. It then reached the surrounding distribution channels, which spread the water evenly across the entire structure. From there, the water first trickled out of the distribution channels onto the so-called drip distributors, where it was broken up and dispersed into smaller droplets. This step was essential to increase the surface area and improve the cooling efficiency. It then trickled further down through the underlying wooden structure, where it continued to spread out and cool as it moved downward. At the same time, air flowed upward through the tower, driven by the natural chimney effect. As the water trickled down through the underlying wooden structure, it was effectively cooled while continuing to spread out. A small portion of the water evaporated in the process and exited the tower at the top as water vapor, before the cooled water was returned to the cycle.